do it in perhaps a way that it's probably more complicated than it should be, but I want you to see ways in which we can break this problem down. Now the question is, I have A, B, C, C, D, but I only have 4 locations. I want to know how many 4-letter arrangements I can make with these 5 letters. But these arrangements have to be different. Well, I can think of it. Let's say, okay, so I have the ones where there's only one C, right? The ones where there's only one, B, C, the one where there's only one C. How many of those are there where there is only one C? Well, there's going to be 4 factorial. So you're going to have 4 factorial with only one C, right? Now, how many am I going to have with 2 C's? By the way, 4 factorial is 24. So how many am I going to have? How many different arrangements are there going to be with 2 C's? Well, here's a way to think about it. Now, since I'm going to be taking both C's, these C's could be allocated into 4 different places. Spot 1, spot 2, spot 3, spot 4. So I could put the C's in spot 1 and 2, or spot 3 and 1, or 1 and 4, or 2 and 3, right? There's all these locations where I could be putting the C's. I can even count them manually, and let's do this for now. So I could have them at 1, 2, in 1, 3, in 1, 4. I could have the C's in 2, 3, and in 2, 4, and I could have them in 3, 4. And that's the different places where I could have the C's. Note that I'm not counting 3, 2 as a different ways, because that would be the same. It would be the same to have a C and a C here, as it would be to have a C and a C here. That's exactly the same thing. So I can't count for those. Now, there's a short way to do this, which I'm going to show you in a minute. But right now, I just want to see that I have 6 possible places where I can put my 2 C's. And what do I have then? Well, for each one of those 6 places where I can place my 2 C's, I'm going to have to choose 2 letters, A, B, D, and for each one of those, arrange those 2 letters out of these 3. How many ways can I do that? Well, that's very similar to a previous exercise. I have 3 letters, A, B, D, and 2 remaining spots. How many possibles can I do that? 3 times 2. So 6 times 3 times 2, that's the possible ways in which I can place the letters when I'm using both C's. 6, because it's the different places where I can put the 2 C's, and 3 times 2, which is the other things I can do with the other 3 letters. And this is going to be equal also. This is going to be equal to 6 times 3, 18 times 2, 36. So the total is going to be 24 plus 36, which is going to be equal to 60. So it's actually very interesting to think about it, and I had absolutely not realized that this was going to happen. Then we get the same number of different possible arrangements. Quite frankly, I'm wondering whether there's a mistake here, but it seems to be correct. Can you please check? And let me know what you find out. I'm going to move on to just to close down a little bit more on counting principles. So, arrangement. This is what we really had to begin with. And what we had to begin with, we said, well, here there are 4 letters, and we figured out this n factorial technique. How many ways can I arrange them? If I limit down the number of locations I can put them to 2, I would do n factorial divided by n minus r, where r is the number of elements I'm choosing from my list. In this case here, I would have n would be 4, which is the number of elements in my list, the 4 letters, and r would be 2, which is the number of elements of that list that I'm choosing. Now here's something interesting. Here's the other formula, other tool that is in your syllabus that you have to learn how to use, and which is actually very useful. What happens if I do the same exercise as before, the one I did with 1, 2, 3, 4, 5, and think of how many numbers of 2 digits can I write with those two? But in this case here, I'm going to change it a little bit. I'm going to have Peter, Paul, I don't know, Mark. I'm going to have Luis, and I'm going to have Jim, just because it's a short name and that way it fits. If I have 5 people, which is very similar, and I'm going to choose a pair out of these 5 people. It's very similar, isn't it? Here the answer, remember, was 20. Right? And I actually calculated this using this formula. But what's going on here? Well, it happens that if I choose Peter and Luis, it's exactly the same thing as choosing Luis and Peter. It makes no difference. If I'm going to choose a pair out of these 5 people, the order in which I choose them is indifferent. So what I can do is I can divide by the number of things that I'm choosing. It's going to be exactly the same formula. And this, you know, is going to give me 20, because that's the different possible pairs I can make. But the thing is that I know, like we saw before, that there's repeated pairs. I have Peter Luis, but right now, somewhere in this counting, I'm also accounting for Luis Peter. Since I know that everything is repeated 2 times, all I have to do is divide times 2. And that's the number of elements that I'm choosing. So all I have to do is divide by r factorial. And these 3 are going to be our 3 new techniques for you, which I don't know whether you knew them or not, but they are very useful for counting fast. The most useful tool, remember, however, is your mind and your own ideas. This one is when I'm choosing all of the elements. I have 4 elements, and I'm going to make all possible arrangements using all of them. This one is when I'm not choosing all of them, so I shorten it down by dividing. So instead of doing 4 times 3 times 2 times 1, I just do 4 times 3. And it looks a bit complicated, but really it's not that hard, it's just to stop. And this one here is again the same thing, so the same thing as the previous formula, but I'm going to divide by the number of elements that I'm choosing to take away those that are repeated, to take away the pairs which are repeated. So with these 3 formulas, and most importantly with your practice and thinking, you can do counting principles exercises from your exam. I just want to add the counting principles world is a world which has either, you can have very simple exercises and extremely complicated exercise, even for super smart mathematicians who really struggle with counting principles exercises at times. They can be really tricky. So if you go to a book, if you go find out, if you go on the internet and look for stuff, you might find out some seriously devilish exercises out there. Take it easy, practice, and just think about it carefully. Try to start going for exercises with small amounts of variations and just applying these formulas. That will help you visualize. And then you can move on to more complicated questions where the number of variations is going to be on the millions or trillions. That is okay, you'll be able to figure it out because it's just a small application of these formulas. I hope this helps you, and by the way, do get back to me on that one. Were they both really 60? I do wonder, maybe we should just make a list. Thank you for watching, goodbye.